So folks, thank you very much. We're really sorry, it's really cold here. I think Iva and I brought you the weather from London, so cool.
Cool. Well, hello, I'm Iva, and I joined as a grad a few years ago in the security architecture team. And our talk today is about the journey that I have actually witnessed firsthand of the team from the kind of a very manual process to what it is today and what we're building. And yeah, Aldwin and I will tell you about the 5 fundamentally transformative changes that we've built in the process. So yeah.
Cool, thanks, Eva. I have a few hats. One of them is with Eva to run a team of security architects. We focus on security consulting services. Think about the intersection of institutional knowledge and domain of expertise, and also security assurance. So this is what we are delivering security reviews of what we're building internally. But first, you may notice that there's a bit of Olympic theme in the slides. Is because when Eva and I had the idea for the talk, it was in the middle of the Olympic season being hosted in my native country. So the original idea was one Olympic ring for one transformative change. But before we get there, how many folks in the room are architects? Do we have any architects? No, we have a few. Any security architect as well? Any architect? Okay, brilliant. To be fair, I've always seen my role as a solution architect. But, okay, so moving on. So some of the challenges we're facing, so we have gates in our environment where based on the potential of an application that has been built to introduce risk that will exceed our appetite, you have to go through a security review process. And the challenge is if it's security as an afterthought, not baked in, just if a developer will incorrectly assume it's a rubber stamping exercise, then identifying a fundamental design flaw at the last minute, having to go back to the whiteboard, if we do identify a fundamental design flaw, it can add a lot of delay. Also, there's the perception as well. It's very tempting for the developer to blame it on the security folks, right? Of course we're late. It's a security issue. So one of the things we wanted to, so on the next slide, you'll see, so TraderX is designed to be a distributed reference application in financial services domain. It can be used, it's open source, it's a FINOS project. It can be used for experimentation. And one of the things that we would like to do, and this is probably one of the most important things to remember from this talk, it's a call for volunteers. And we would like to, Eva and I will show you what we've done with MySecureBank internally. And the goal is to create an open source version of MySecureBank using TraderX. MySecureBank is used to deliver security training. In my experience, you can provide security guidance to developers many times, but the second you actually show them how easy it will be for a threat actor to exploit, suddenly you can see that magical moment where almost the light bulb turns on top of their head, right? And I promise you they will never ever make the same, they will never open the control gap, they just have to realize how easy it will have been to exploit. And in our experience, many of the gaps that we identify all the way from a vulnerability to a fundamental design flow stem from developers making assumptions that are incorrect. And we will show you that this is what MySecureBank was designed for. And please have a look at MySecureBank through the prism of, Eva and I would love to work together to create an open source version of MySecureBank across the industry. So you'll see, so here, this is the login page. So the goal here is to come up with the most visual, the easiest to, a very simple visual demonstration of each control gap. At the end of the day, you may have incredibly more complex flavor of that, but the fundamental issue is always the same. So here, if someone attempts to log in with a username that is recognized and not a valid user as opposed to a valid username, the obvious takeaway here is that there's too much information. It seems really trivial, but you have incredibly more subtle version of that. It could be an API, the response of an API call that has a 1 byte difference on whether or not the user is valid or not, right? So being able for developers to realize that the error message should be as generic as possible is really important. Also, in the spirit of having much more subtle flavors of the same issue, think about an application that based on, if the username is valid, you may trigger some fraud detection, some fraud logic. So the business logic may be a little bit very different. So the cut path will be different based on whether or not the user is valid. So by carefully monitoring the amount of time it takes to get a response, you can infer from there whether or not the username is valid. So see, these timing attacks become a lot harder to mitigate, right? So once we've logged in,
yep, now we've logged in, and My Secure Bank aims to emulate your regular online banking application. It has the same functionalities you would expect in such an application. So you can see a list of previous transactions for the account. You can generate a statement for previous month. You can transfer money, of course, and you can manage subscriptions to the bank's newsletter, for example. So if I go back to the landing page, I can see that the account number that's displayed here is also a parameter in the URL of the page. So if I decide to change that from just the number ending in 001 to 002, suddenly I'm logged in as Aldwin. And I can see his full list of transactions and can do the same actions as he would be able to.
Exactly. So you will tell us, oh, nobody will do that. You'll never find an app that has that. At the end of the day, it could be incredibly more subtle or more hidden within a parameter that is not exposed in plain sight. But the issue is exactly the same. It's a deficient authorization mechanism. It's been in the news so many times with well-known mainstream applications that have been proven to be vulnerable to that. So here, again, look at it from the perspective of, it will be amazing to have an open source version of this application built on top of TraderX in collaboration with the industry that we could use to deliver security training, or at the very least, raise security awareness. For example, as I mentioned before, many of the vulnerabilities we uncover stem from developers making assumptions that are not correct. Iva will show you how one of the assumptions that is incorrect is the belief that if you have an application that is not internet-facing, an external threat actor is not able to exploit any gap in that application. And we'll show you that in just a moment. But in the meantime, you can see a search field here. So obviously, so it calls for SQL injection, right? And you'll believe SQL injection is a thing of the past, but still, so here, Iva was able to inject meta characters that have a special meaning based on the context. And you remember the first issue we found, here the error message already gives too much information. So the error message discloses the type of database that it is. So armed with that knowledge, an attacker, it only makes it easier for a threat actor to, from there, to query system tables. Each database has system tables that, so here first, Iva is exploiting the SQL injection a little bit further and is able to pull all the transactions for all the accounts. Then the next step will be to query the system table that will actually disclose the SQL queries that were created that were executed to create all the tables. So you'll see that in a second. There you go. So here you can see the SQL query that were used to create all of the tables, and from there it becomes really trivial to actually pull the list of users and potentially credentials as well. So here again, it seems, there you go. So you can see this is a list of user with password. And you can see that, so this is a good opportunity. Typically, when we provide security training with Iva to developers, this is a good way to talk about the principle of least privilege. How come this application had access to system tables? It doesn't need access to system table, right? Second, defense in depth. Never solely rely on a single defense mechanism because it may fail. And when it fails, then there's nothing else. I talked at the beginning of, we introduced, well, when we had the idea for the talk, it was the Olympics in Paris. Think about the French medieval castle. You have all those layered defense, right? So defense in depth, exactly the same concept.
And maybe enforce password complexity and hash the passwords. That's probably also a decent idea.
Absolutely true. Yeah, to your point, not a good idea to keep the password in plain text.
Now, going back to my actual list of transactions, we can see that the last transaction was my lunch or dinner, and in the usual scenario, I'm logged into my online banking account, and then I get distracted and I decide to open a link. So I open this link. Someone sent me a link. I just clicked on it. Sorry. Correction. Yeah. No. Yeah. Sorry. Yes. Correct. Link. And if I refresh again my transactions list, I can see that there was an additional transaction that I probably didn't intend to execute, especially definitely not to malicious blog. So what happened was actually I see the broken image tag at the end of the page. So what's happened here is actually when the browser tries to cache the image and load the image in that malicious blog, it makes an authenticated call to the URL, and it actually executes a transaction in my secure bank where I'm already authenticated. And a similar flavor of kind of a similar attack that could be exploited is the another link that I've been sent, and I'm reading the blog. Probably need to refresh my Latin for that one. But if I go back again to the list of transactions, I see that I've actually, without intending, sent money again out without doing anything on my secure bank. So what happened here is actually the My Secure Bank image. You can probably see it very faint. The My Secure Bank page was embedded in an iframe, and it's specifically positioned underneath my cursor. So every time I click, I actually click on a very specific place within the page, and that executes a fund transfer. Now, for the next one, I'd like to just quickly direct your attention to the messages from the financial advisor here. And it's just communication correspondence with my financial advisor. Sometimes this could contain some sensitive information. So if I go to, a URL that is external in this case, and click on the image, I'll actually show you the stack trace. Let's refresh that. You can quickly see that the list of allowed origins is probably overly permissive, being a wildcard.
Exactly. So we use that example to show this is an app that actually realistically is running locally on Iva's host in a data center somewhere, absolutely not exposed to the internet, but it will be trivial to exploit from outside of the by someone on the internet simply by tricking an entitled user into visiting a malicious link. And here, there's no exploit in the browser. The browser is up to date. It's just a vulnerability in the app. And also what we've seen, it's very easy sometimes when you have the controls in lower environment, eventually it doesn't work. And someone comes up saying, oh, if you put that wildcard here, it does work. And maybe day one, you may have a service that is consumed across shared between different apps across different domains. which may not expose sensitive data. It could be a service that vends market data, right, like stock price, right? So really not sensitive, but eventually, as the requirement may evolve, you may end up vending much more sensitive data. So what was not a security issue now becomes a security issue. Or simply where the control was in place, eventually the control is removed. You have also there's a much more legacy flavor of that with JSON. This was called cross-origin resource sharing, which is a proper way of doing cross-domain calls when the control is in place to only authorize the legitimate domain that is meant to consume that server. A very bad way of doing cross-domain calls is with JSONP. So you can see there's a service from a different domain here. We use that to show how the application is calling a shared service over. So basically, it's just it's a script tag. It's an absolutely terrible way of calling that service. Long story short, it's vulnerable to the exact same issue. Iva is showing it to you right now. There you go. So if a threat actor is able to trick the user into visiting some external malicious site, the malicious site will be able to access, to consume the server. You can see here, it's just a strip tag. And it was very popular a few years ago. And again, it could be totally acceptable if the data sets exposed by the service are not sensitive. But eventually, you may end up putting a lot more sensitive data sets here. And simply by tricking you to a legitimate user to go to an external website, we have an issue. Maybe one more. Let's talk about, so here, at the bottom, this widget is actually a WebSocket, right? So after the HTTP handshake, you do have a bidirectional TCP connection. And it's vulnerable to exactly the same type of issue where it's actually called cross-site WebSocket hijacking attacks, where if so here again, maliciousblog.com, this is a real website, by the way. This is a real external website. There's no hack. It's literally an external website that opens the same WebSocket. However, because the server of the application fails to validate the origin of the caller, then simply by tricking a legitimate user into visiting the external malicious website, the malicious website will be able to pull all of those data sets, right?
How are you maintaining persistence? How are you maintaining persistence for the WebSocket connection?
It's authenticated, it's just a TCP connection that is authenticated. The problem is when you do the HTTP handshake before flipping to that TCP connection, the server, the service provider needs to check the origin of the page, which often it fails to do, right? And there were a number of cases in the industry where actually this exposed, this vulnerability was, well, exactly the same vulnerability.
Now, if we go into the fund transfer, another quick example of an assumption that could be made is, so we have the functionality to transfer money into our savings account, so from checking account to savings account. And as you can see on the UI, we can't edit the recipient account. However, if we actually try to inject some JavaScript into that,
It's okay. So this is really interesting because we find, so fundamentally the design flow here is when you have, so the business relies on the implementation of controls. And many times the control will be there. However, the implementation will be deficient. So here is an example where the control is there. The legitimate user should only, the user should only be able to wire money to a low list of recipients. However, it's not enforced on the server side. And it looks trivial here with a line of JavaScript using JavaScript as the protocol handler in the address bar of your browser. It allows a malicious insider to execute arbitrary statements within the context of their session. However, here, because the logic is not enforced on the server side, it can easily be bypassed, right? Maybe even for the interest of time, let's go back to the presentation. But folks, the bottom line here, what we really want to do is to come up with an open source version of that, and it's pretty much any vulnerability, regardless how complex it is, I can assure you, regardless all the way to injecting regardless of the complexity of the exploitation, the root cause is something that can easily be modeled using a very visual example, and that's the goal of My Secure Bank. And it worked amazingly well. I've seen developers suddenly realizing the vulnerabilities they had open, and they had never thought about how easy it would be to exploit, right?
So, going back to these slides, so this is My Secure Bank was a tool that we used to kind of try and provide some security training. And now going back to the journey that we wanted to share with you. So previously we mentioned that the SecArc review process could often be perceived as a sort of 11th hour rubber stamp approval that you need to get through, but it is an external dependency for dev teams. It is something that they need to wait for. It could be a blocker. And to Aldwin's point, quite often if we find a security gap, a control gap, after the application has been built and just before it goes to production, then it is very expensive to remediate. So in order to allow system owners and actually encourage them to engage with us as early as possible, we created a permit to build. And the idea is that the permit to build is just a design review, ideally while the design of the application, the architecture is still being decided on. It's still on the whiteboard, no code has been written yet. And that gives benefits to both sides. So firstly, for us, from a security perspective, it allows us to provide security guidance early on, knowing what is going to be built, and we can help define which controls need to be implemented. But also from a system owner perspective, it gives people assurance that if they build what we've agreed upon in the permit to build, then they will get their production readiness, production level approval. And that production level approval is what we call permit to operate. And the main difference here is that the permit to operate also captures evidence of the implementation of the controls that were laid out in the permit to build. So that's why it is typically a bit later on in the development lifecycle. However, even though permit to build and permit to operate, having two separate reviews worked very well and already was great progress, we realized that sometimes the permit to operate could still become a blocker, could still be a last-minute dependency for teams. And that's where we introduce straight-through permit to operate. And the idea is that if the system owner has an already approved design, so they have a permit to build, we've reviewed the application and have provided the security guidance, then at the time where they need to submit the evidence and get it approved, they don't need to wait for us. They can actually get the evidence validated by one of their peers. So that removes us as a security team from the critical path of going forward to production. And of course, after the fact, in a non-blocking manner, once the permit to operate is approved, the straight-through permit to operate is approved, we still go in and validate the evidence and check. But again, that's not meant to block in any way the team. Now, one caveat that I mentioned about straight-through permit to operate is that you need to have an approved design. So the design has to be reviewed already. And if the team is using a well-known, well-documented pattern in the company, then why would they need to wait for us to just confirm that, right? So that's why we introduced straight-through permit to build. And the idea is, again, if you're using a well-known pattern, if you're not deviating from it, then you can get your permit to build very quickly, again, without any dependency on our team. So the combination between straight-through permit to build and straight-through permit to operate gives that full self-service automated path through SecArc. And we did mention the theme of 5 transformative changes linked to 5 Olympic rings, but there's only 4 changes on the slide. And I'll ask Aldwin to tell us more about the 5th one.
Well, the 5th ring. So wouldn't it be amazing if there was a way to have a machine-readable format that will describe what you're building? And if it was possible to do that, then suddenly you don't need the interaction with the security architect, especially if developers are simply building an instance of a well-known design pattern. It will be possible to do all the security review based on that format. So Denise actually, I think, here is going to take a deeper dive in this model. So it's tomorrow at 3:45 in the Winter Garden, Architecture at Scale, with David. So we're not going to cover it too much. We've borrowed the slide from Matt Bain, but the whole idea is to create a machine, like an open source, machine-readable format that will describe what you're doing, and that we could leverage to ensure and to programmatically check that all the controls are there, right? So Denise is going to talk more in detail about that with Architecture at Scale tomorrow. And Rishi, in the same Winter Garden room today at 5 o'clock, is going to talk about governance using architecture as code as well, very similar to that. Talking about call for volunteers, this is meant to be a common language to describe the architecture that you're building, sort of lingua franca. And we do need your help to build it together. There's a call, it's the last Tuesday of every month. Typically, Matt Bain actually hosts that with some of his colleagues. Here, you can see a beautiful C4 diagram on the right-hand side that describes TraderX, which is the open source application we mentioned. And you can see here, it's on the GitHub, the FINOS repository. This is the architecture as code version of it using Calm. And coming back to the original fifth ring, imagine if, as a developer, you're building on you're using an instance of a well-known design pattern. If you're using a platform, the platform that is provisioning the infrastructure for you, how about having that platform make an API call to the security architecture folks to say, look, this is exactly why it's been built. We know because we're building the underlying app infra. We know all the controls are there. So you can think of this as almost, you got your the security review will be done, but as a developer, you don't have to initiate anything. It's almost as a byproduct of the design choices that you're making. So in other words, if you are using that golden path, if you're using well-known design patterns, the security review will be done, but will be the path of least resistance. It will be completely, to Iva's point, automated, as opposed to not following those design patterns, right? So bottom line is we do need your help. It's really meant to be a collaboration across the industry. You can see we had a number of on-site accelerators that we hosted ourselves in London, in collaboration as well with the stock exchange. You can see the London Stock Exchange. Bottom line is please do join the call. Well, if you would like to be involved, it's the last Tuesday of every month. Denise is going to talk more about that architecture at scale and the model. But please come and Iva and I will be around, so please come and talk to us either tonight or tomorrow. Yes, Denise.
So I'd like to my secure bank. If I want to get engaged, how do I get engaged? What's the way for me to kind of contribute, consume, and be a part of that?
I think probably the best way is, in terms of developing TraderX as a new version of My Secure Bank, is just joining one of the FINOS meetings that we have.
And also feel free, thank you for the question. You can email, so firstname.lastname@ms.com. So it's in the agenda of the conference. So firstname.lastname@ms.com. Please do ping us. We would love to hear your feedback. We've used it for all the way from raising security awareness to ensure that those assumptions are not made, all the way to deep technical training. I mean, we've run sessions for several hours actually with this app, because we can talk about the remediation strategy. We can talk about how to mitigate it's very engaging. It's a live demo, and we're convinced it will be amazing to do as an open source version. So please do join. Thank you. Thank you very much.